All right, in this problem, a hot air balloon is rising vertically from a point 200 meters away from you. You observe that when the angle of elevation is pi/4, so 45 degrees, the angle is changing at a rate of 0.05 radians per second. And we want to find the vertical velocity of the balloon. So we want to find how fast the balloon is rising up, right? It's rising vertically. So let's start by drawing a picture. So the first thing I want to do is just kind of draw a little horizontal line here to represent how far we are from the balloon, right? You're over here, let's say. This is you, and then the balloon is rising from this point over here. Okay, now let's say that let me just, here's the balloon. Okay, I'll draw a little hot air balloon. That's our hot air balloon. And it's rising vertically from this point over here. So let me just draw a line here. Oops. Okay, you get the idea. So now this is the height of the balloon. I'll just call that h. And I know this is 200 meters. Okay, that's 200 meters. And it's not changing, right? It's not changing. And then the angle of elevation, let me draw this a line up here to the balloon here. Actually, you know what? I'm going to make it a little bit, I'll make it here. Okay. So the angle of elevation is this angle right here. This theta is the angle of elevation. All right. And what we want to find, what do we want to find? We want to find dh dt. We want to find how fast the balloon is rising. Okay, how fast is that height changing? All right, well, I guess first of all we need an equation here relating theta and h. And what I see here is I'm given this adjacent side and the opposite side is h, so I can write a relationship, right? I can write tangent of theta is equal to h over 200. That's easy enough. All right. So now I want to find what do I want to find? I'm given, let's see. I got to make sure I write down what I'm given. Let me write it down here. I'm given that the angle is changing at this rate, right? So this is what we're given is d theta dt is equal to 0.05 radians per second. Okay, so we're given the rate of change of the angle. And that's at the point when let's see, theta is equal to pi/4. Okay, at that particular point when the angle is pi/4, the angle is changing at a rate of 0.05. And this is in radians, of course. So I'm just say when theta is that. All right. Well, all right. So we have this relationship, and let's just go ahead and differentiate both sides here, because we know that the derivative of tangent is secant squared, right? Secant squared of theta, but then keep in mind theta is a function of time, so theta is the inside function, and we have to use the chain rule. So we're going to multiply this by d theta dt. Okay, so over on this other side, I have h over 200, which is the same as 1 over 200 times h. But when I take the derivative of the right-hand side here, I'm just going to be left with 1 over 200. But again, I have to remember that h is a function of time, and I have to use the chain rule. So I'm going to get dh dt. So 1 over 200 times dh dt. All right, that's what we're looking to find. So if I just multiply both sides by 200, right, I'll have it. So I'll have, let's just do that. Let's just go 200 secant squared theta d theta dt is equal to dh dt. All right, we're getting there. Now, really all we need to do is just put in what we know. We know theta, right? We know theta is pi over 4, so we're going to have 200 secant squared of pi over 4, and then times d theta dt, so 0.05, and that's going to be our dh dt. So what do we get? We get, I'm just going to write this over. dH dt is equal to, so I have 200, and then secant is one over cosine, so I'm going to have, what is it? 2 over square root of 2 squared, and then times 0.05. Okay, multiply that out, and I got 20. 20. You can actually do this without a calculator, but you could, I'd probably let you use a calculator on this one. Now the units are going to be meters per second, right? Because our height was given in meters and our, the d theta dt was in radians per second, so we're going to have meters per second. All right, so that's telling us that the balloon is rising at 20 meters per second, given the information about the change in the rate of that the angle of elevation is changing. All right, I think that's it. That's all we have for this section, and I'll see you in class.